That's gonna help you. Believe me. Okay, so let's go back into this. Your previous homework assignment was to have your add screen update an array list instead of just having a single employee, correct? And we didn't actually solve that in last class, but it should have been a pretty easy assignment because last class we looked at array adapters. So let's bring my code up to date with that here real quick. So I'll go to my employee entry activity. Or did I solve it? I don't remember. No. Okay, so right now inside of my singleton, I have just a single employee, right? So what I'm going to do here is I'm just going to go into my singleton. I'm going to change this guy. Well, here, I'm going to say this guy is a array list of employees. And we're going to call him the employees. Oh, I actually already gave myself my array list. There we go. So there's my array list of employees. Oh, so what I artificially fill him with stuff someplace else? All right, I put some strings in someplace else. Okay, so I have my array list of employees, and what I want to do is I want this guy to get filled up from my employee entry activity. So here's my, I'll go ahead and just give myself a temporary employee variable. We don't actually need it, but sometimes it's a little bit cleaner to see it this way. So after the user creates an employee, hits an employee button, and they create a new employee, we'll go ahead and actually create an employee object. Now, what do we want to do with that object? We want to add it to our global array list. So we'll say core.theemployees.add temp employee. All right, so that's what we'll do there. I'll go ahead and get rid of some of this. Actually, I'll leave that in there because that was when we had looked at the having a result stuff coming from your activity. So just is this old commented out code. So after we add our employee to our list, we'll go ahead and just tell this activity to finish, which will go ahead and go back to the main screen, right? And we have a brand new employee added to our list. Okay. So any questions on that? That was the homework for last class, right? All right, so everybody's got that? So we have a collection of employees up in our singleton. And on this add employee screen, we create a new employee, we add that to the collection, and then we're done. Okay? Now we want to have a screen that is a list. So here's our employee list activity. Now, we talked about this idea of an array adapter last time, and I showed you this thing in here where we went ahead and we had our employee list view, and then I created this just array of strings. So I made you connect a couple of dots for this assignment, but just to review what we did last time, we have this array of strings completely unrelated to our employees right now, right? And then what do is we create our array list of strings and fill it up with some strings. So this was two different ways we can create our array adapter. Our array adapter will work off of a string array. It will also work off of a array list. Two different types of collections we can operate with. What's the advantage of an array list over an array? Go ahead.
You can add any amount to it with array. The size is set once you create it.
Yep. So one's not necessarily better or worse than the other one. It's what's the right tool for the job. If you don't know how many things you're going to hold, for instance, we don't know how many times the user is going to click add new employee, right? We need an array list or something like an array list. That is a elastic collection of things, okay? Otherwise, if we know exactly that we're going to have 1,000 things, for example, we can go ahead and just create an array capable of holding 1,000 things and fill it up. In fact, under the hood, that's probably faster in terms of real-time performance and more memory efficient and, well, probably probably more memory efficient than an array list, not more memory efficient than some of the other elastic collections like linked lists that we haven't talked about yet. We spend most of next semester talking about those data structures. But in any case, these are not, one's not better or worse than the other. One's not an upgrade to the other. They just solve slightly different problems, but both of them are collections of things. In either case, whether we have an array of strings or we have an array list of strings, we can create an array adapter. An array adapter adapts an array, adapts a collection of strings to a row in a list view. Okay, that's what it does. It adapts your data to your interface. So we're actually seeing MVC kind of in action here, right? But instead of it being generic MVC where I can, manually make things happen in the between my interface and my logic, now we have this specialized tool called an array adapter that says, look, if you give me a collection of stuff, collection of strings, in this case, we're going to look at a little bit more advanced version of it today, but if you give me a collection of strings, and you give me what a row looks like, one of the generic rows that knows how to hold a single element, I'll go ahead and adapt that collection to that row. I'll marry those together so you don't have to do that yourself. That make sense? All right, so that's what an array adapter is for. So notice we built them in terms of both our array and our array list. Doesn't matter. And then we went ahead and set our list views adapter to either one of those adapters. Whichever one we wanted to set it to. It takes an adapter and it will display whatever that adapter says. It'll say, here's your data in terms of these rows, in terms of this layout. All right, so in this case, we had a whole bunch of strings, right? Now, what we're going to do, I'm going to gut this a little bit. In fact, actually, here, let me, I'll comment out all of those things for now. We'll just write some new, just so you have some. And I'll get rid of this very first array adapter. We'll just use the second one. All right. Actually, no, that's fine. We'll just use the second one. So what I need to do now, since our generic array adapter only knows how to adapt collections of strings, right? That's all he knows how to do right now. We're going to go ahead and we need to turn our collection of employees into collections of strings. So I'm going to go into my employee object here. You didn't have to do it this way if you didn't want to. Oh, we actually already have it. We already have a toString method that returns the first name and the last name of our employee. And is that what we're supposed to put in our rows? First and last name? Okay, so an employee already knows how to do that. So I'll go back into my employee list thing here. I'm going to create an array list of type string, and we'll call this the employee names. And this will be a new array list of type string. So right now it's empty. Now what I want to do is I want to go through every single employee and fill this array list up with their name. So for int I is equal to, actually I can show you a for each loop for this. So we can say for employee E in core dot the employees. Because array lists are what are called iterable. So let's go into, so I could have also done for int I equals 0, I is less than core dot the employees dot size, I plus plus, normal standard for loop. But we do have something called iterable. What do you think iterable is? What kind of animal is that? Cat, dog, class, interface? Because of the able. Okay, so the iterable interface. Things that implement this interface can be iterated over with a for each loop. So we can go through, what does that mean? We can go through each element in a collection without having to index a specific element by bucket number. Now, sometimes you actually want the bucket number. You want to say, I'm at bucket 2, or I'm at bucket 3, or I'm at bucket 4, especially if you're like searching for something. Where is the value I'm looking for? But in this case, I just want to take everything that's in this array list, and I want to put a version of it into this other array list. So I just want to go through every single guy. I don't care if I know I'm at bucket 3, 4, 5, or 7. Okay? So something that follows the iterable interface, which I'm actually making the assumption that array list does, but I'm pretty confident. Array list Java. We'll go to the Java documentation for this. Yeah, here we go. He follows the iterable interface. And here's all the things that follow the iterable interface, and you'll see a lot of them are listy things. And the iterable interface has a version of the for each implementation for it to work. It also has this awesome method called splitterator. Doesn't that just want to make you call that? who wouldn't call a method called splitterator? All right, but for our purposes right now, the idea is that something that follows the iterable, something that implements the iterable interface is something that we can use within a for each loop to go through every element of it, and it's a little bit more convenient for us. So if we come back in here, I'm going to say for each employee E in this collection of employees. So each time through, E will be equal to the next employee in the list. So the first time through, it'll be the employee at bucket 0. Then E will be equal to the employee at bucket 1, the employee at bucket 2, so on and so forth. All right? And we could call this guy, emp if we want. It's just a variable name. We can name it whatever we want. Okay? Some other languages will write this as like for employee E in. Actually, you saw this in Python with the in word, something in some collection. Yeah, so I probably prefer that. I think Java's syntax here is a little bit wonky. Just separating it by a colon, saying for each of these in this collection. I'm reading this as in, so why didn't they just make that the word in? I think maybe it would have been a better syntax, but whatever. It's the way it is. So for each of those, what are we going to do? We're going to say the employee names dot add e dot toString. So I'm going to fill up this array list of strings with only the first and last name of all my employees as strings. And then I'll build my array adapter in terms of my employee names. And now I have a list of employee names. All right, so that should be it for the homework. So if I come in here and run it the first time, we're going to be writing that before too long, by the way. We at least write it next semester. Oh, give me a moment. This is still our code left over from when we were checking about on resume coming back. But remember, I'm no longer have a core.the employee, so I'll just comment out the on activity result and everything, since we're not doing that right now. And actually, a good rule of thumb, something you saw happen there. Notice when I went into core, I kept my list of employees, but since I was no longer using the employee, my single employee, you would either comment it out or remove it. Commenting out is fine if you want to remind yourself of the syntax, but by removing it, what did I do? I was automatically reminded by the compiler that all the places I've used it. Make sense? So I can go and address those one at a time rather than having these like leftover logic in my code, which may not be a problem, but also might make some changes that I didn't intend. All right, so this is just kind of giving ourselves a little, putting a post-it note on it by me taking away that variable. Now any other place in my code where I use that variable, it's gonna have some issues finding it. All right, so I fixed these two errors now because I've just wrapped it in a comment. Remember, this is our code from when we were practicing with our activity lifecycle on resume, and also an activity giving us a result, which is something that I would say you will, I guess I don't want to necessarily say that you will rarely use this approach, but now that you've learned about singletons, I think you will likely not use this approach very often, because the one piece we haven't seen yet is how do we handle this result thing? And I'm going to show you that here in a few minutes. Let me just get this working, show you this working first, and then I'll show you kind of well, what if I want screen 1 to know something about what's happened on one of the other screens? How can I accomplish that without this whole on activity result thingy? Make sense? We can still do that through the singleton. Somewhere in this line of thinking, I'm probably showing you the way that I prefer to do it, and not necessarily, I mean, Android obviously put this on activity result thing in here because that's what they deemed was best practices. We can all, as a group, probably say with confidence that the more screens you have to send stuff between, the less convenient putting things in put extras is. That doesn't mean don't do it. You know, I think my overarching lesson would be always use the right tool for the job, or at the very least a reasonable tool for the job. Sometimes the right tool can be misleading, right? But I would say that I write and have written a lot of Android code over the last decade, and I very, very, very rarely will use this. In fact, the only time I might use it is when I have to show an example in class. Just here's the existence of it. I will almost always do things through singletons or some other interesting solution for the problem. I just don't like the idea of calling an activity for that activity giving me a result. It doesn't feel like a natural way of solving a problem to me, even though Android has kind of put it in there as a recommended approach. Okay, so somewhere in here you're kind of getting the Mike Littman version of how I would do these things, as opposed to maybe what you might go into an internship or something like that, and they might use this on activity result stuff all the time. So I'm not saying it's bad. I'm just saying it's not my preferred method of doing it. Sound reasonable? And of course I'm right. But you'll never lose points for me if you do it this way. It's perfectly reasonable. It's acceptable code. I just think it's somewhat of a waste of time and adds some unnecessary complexity to something that should not be that difficult. You suck. If you use it, suck less. All right. So let's, this should work right now, but then I'm going to show you how to communicate stuff between screens without the on result. So this guy should go away in a second. All right, so if I go to employee list right now, it's going to work. I just have 0 employees. So I got nothing, right? So I'll go ahead and go back. Let's go ahead and add a single employee in. So you know, I had a student the other day, I think I was 55.
How old are you?
How old do you think I am? Nobody who knows how old I am can say that. How old do I look? How old would you presume I am? I've been teaching for 20 years.
30.
So given that information and given how I look, what would you guess my age is?
Well, then that case, 40. Well, like 48.
Yeah, so I'm 42.
That's right.
So I started teaching very young.
I said,
So 55 wouldn't actually be like a horrible guess based on how long I've been teaching. But do I look 55? Maybe I do.
I don't see 55.
It's bad.
Pretty good.
Who gets that?
No, I tried.
It's like- those are you're 42, but you look 55. That's the bad way, right? It's like those have been some hard years. All right, so and then weight, $1.75, of course. That's actually another follow-up interesting question. What's the latest I can put in there and have it be believable?
For your age?
Well, no, wait,
No,
wait.
Like looking at him, what do you?
What does it mean to be light for age? So, like, if I put in 290, would you believe that? Like, it's possible I could be 290. Is that just that one of those things that's like a heavy enough weight that it's outside of most people's like knowledge base? They're like, yeah, that seems really heavy, so that's probably works.
You're pretty tall, so.
Your height shows it off.
Does it?
Yeah,
Yeah.
because you're like significantly taller than the average person.
Yeah, I mean, when I was in India, they were calling all the people said I was the what's his name, the wrestler, Big Show. They were taking pictures with me like they thought I was the guy.
Signing autographs.
Yeah, you guys sign autographs for a couple bucks.
I did. I was signing. I didn't charge for it. I would have just gotten rupees or something.
Coolest wrestler we've ever
Shave
seen.
empty.
All right, so I just added one employee. We go to our employee list now. We got one dude in there. I'll come back. We'll add another employee. We'll just bang on the keys.
Yeah, I can see the. I can see there was a one.
Grow a beard out. You can see it.
Well, that's yeah. Usually, I'm doing an experiment right now.
Experiment.
You notice I have hair?
Mhm.
Yeah. My wife challenged me because I get bald back here and I don't like the side hair. But she said, "Oh, why don't you try growing it out?" So I'm gonna go like, I don't know how far I'll be able to go. But I'm gonna try to go like hippie style.
Yeah, get a mullet.
If you grow a mullet,
That would be.
I'll pay you $500.
That'd be
That's
legendary.
something.
Could you imagine like rolling up at the end of the semester and just seeing like a mullet?
Well, so is the mullet when it's short here on the side
Yeah.
and long
You know what
here?
they say.
Oh, it's gonna happen because she was complaining about that last night. Because what I keep doing is I have one of those like it's like a waterproof beard trimmer thing. And I keep taking it in the shower and have the setting that because I want the sides to be short. So I'm trying not to touch the side. So I keep shortening the side here, but just letting the top do whatever it's gonna do. So she said at that point it's gonna start looking really weird. She says it's like right on the cusp now. But you're saying I should just keep going with that.
Well,
Keep
does it
going
keep,
with
does
that.
it, is it growing longer like from the backside too? Like you're only cutting it like right here.
Well, I'm just doing everything that until I hear hair cutting all around this the lower quadrant, all the way around.
Well, then you're not mullet.
I don't know.
Cut the back if
You
want
can't
a
cut the
mullet.
back. You have to keep like this
I
strip.
think it's the sides and then maybe the top a little bit, right? I don't even know.
Oh, we're not touching the top. This
Get
is.
a mullet on.
I don't have tons of real estate up here, so I got to just. I'm already shocked. I've got it this good. All right, I think I added another person. So there's my second person. All right. He literally just intermingled working code with a mullet conversation.
There you go,
That's a mullet?
Doctor,
you have to have
I don't know if that's a mullet. I don't know what that is, but
That's a mullet. My friend's growing one right now. I'm trying to find it.
you gotta get those lines on the side too.
Like,
Oh,
if
I
you
do.
can,
I like the
switch on
lines.
side, you could have like maybe.
But at some point, I need to go to a professional. Is what I think. Like they need to, like it's no longer going to be something I can just self-manage. But I probably will still self-manage. At some point, Mr. Gonzalez has been watching YouTube videos to how to cut hair. So
Hey,
You gotta
get
go
Mr.
with
Gonzalez
that.
on it, like get it
I would not trust
ingrained in your hair, and then
Gonzalez.
you'll have the mullet with Mr. Gonzalez on the side, like your two
Yeah.
greatest things.
I would not trust
all right, so we're going to look at a couple of ways that how we can communicate between screens in a new way. Okay? So let's say that on this first screen here, I want to have a big number somewhere that just shows the current number of employees in the system. Something like that. Okay? I can do this a couple of different ways. Now, what's interesting here is we're going to relate this to operating systems. Now, I know a couple of you are currently in the operating systems class. Now, those of you who've had Dr. Locklear and also had me, and I know Professor Locklear is teaching the operating systems class, him and I agree on probably 2% of things. But, so when we have something that we both agree on, it's probably something important, right? We've been friends for a long time, but, we're just a little bit different approach to everything. So, in any case, you've heard Dr. Locklear talk about this idea of the grand ideas of computer science, right? Remember that from 150?
Oh, yeah.
All right, grand ideas of CS. What does that mean? I'm not asking you what are the grand ideas. I know there's like the list of 7, right? But what is that? What's the general idea of actually it's 8. What's the grand ideas of computer science?
The most important things to learn, or the core concepts.
Okay, core concepts of computer science. All right, so we might call this the core concepts of CS. Now, I don't know if he necessarily talks about it in the same way, but I know he thinks this is the same thing. But I like to think of the grand ideas as different lenses through which to view computer science. I think that there is a core truth of computer science. That doesn't say that some of these subjects don't have their own little things that are completely unrelated to other subjects, but there is significant overlap in the various grand ideas of computer science, the various grand or the core topics in computer science. There is significant overlap that this is kind of the argument of why getting an education, a higher education in computer science will help you solve more complex problems. Some of you have heard me make the argument that the difference between like the coding boot camps and then an undergraduate degree and a graduate degree in computer science ultimately comes down into the number of problems you can solve. So maybe the coding boot camp lets you solve, 40% of the problems or something like that. You are very, very good at a very specific set of stuff. You get the undergraduate degree, which, hey, maybe coming out of the undergraduate degree, you actually have less experience. You probably do have less experience of solving problems, let's call it real life problems that you might run into in industry than you would going to a coding boot camp. Because the coding boot camp has taught you a set of skills that will help you get a job, right? But that job is only going to get you kind of an entry level position and kind of stick you there for a while unless you are just an outlier and end up rising through the ranks. What an undergraduate degree gives you is those theoretical ideas, the things that are happening underneath the scenes, these grand ideas of computer science and an understanding at the lower level that might not necessarily seem like you have that much experience applying those things to real problems, right? Some classes are more applied than other classes, and I know sometimes applied things are more fun, but sometimes applied things don't make sense for certain topics. But in any case, coming out with a bachelor's degree, you've had a lot of kind of theory-based education, but maybe not necessarily a lot of applied experience. So relative to somebody who came out of one of those coding boot camps, you might feel like you suck day one. You're not really up to snuff because they've had some experience actually creating end user websites and things like that maybe you just have never done, right? But you have a toolbox that they don't have, that now through experience you're going to catch up to them and then be able to solve more complex problems. Master's degree gives you a deeper understanding of that theory, which now allows you to solve even more complex problems. Does that make sense? So this comes down to the interestingness of your toolbox, not necessarily what you're ready to do the day you step out of insert educational institute, boot camp, whatever, right? Pretty important idea, because I think a lot of times folks limit themselves by saying, well, why pay for school when I can go and do this? Well, if all you want to do is be, a code jockey the rest of your life, which my wife is one of those people. She got an undergraduate degree, but she's been a COBOL programmer doing fairly entry-level coding type stuff for 20 years. Doesn't want any more. Had a 4.0 GPA in undergrad and isn't interested in more. She wants to be the worker bee. Doesn't want to manage people, doesn't want to do anything else, so Could she have gone to a coding boot camp and probably been fine? They didn't exist back then, but the answer is probably, right? But you do close some doors. But in any case, this idea of the grand ideas of computer science, where we have different lenses into the topics in computer science, what we end up finding is we find the same discussions happening when we're in different courses in computer science. So what we're going to talk about right now is this discussion that, for those of you, how many of you in here are in the OS class right now? Just one person, okay. So this is a discussion that hopefully you've had at some point during the semester in the OS class. So we're going to talk about something called IPC, Interprocess Communication. I assume you've talked about that at some level. I know you've done some stuff with it.
Well,
You talked about
you haven't
semaphores.
brought up that term.
Okay, whatever. So
Similar.
the idea is in our computers, in our operating systems, we have, so OS, we have a bunch of running processes. Okay, and these guys are effectively programs that are running on our computer, right? Now, these programs, sometimes they get subdivided on our computer. So they're certainly subdivided among the individual programs. So Microsoft Word is one program running your computer, and your email client is another program running on your computer. All right. Now, sometimes these guys might need to talk to each other. Maybe not, right? Except maybe when you double click on an attachment in your email, maybe there's some sort of communication with Microsoft Word, although it's probably handled by the operating system. But what's more common, especially in multi-threaded programs, so for instance, can you be in your email client, can you be writing an email and still receive email on that email client at the same time? So more than one thing appears to be occurring at the same time, even within a single program. So that would be a multi-threaded application, and the old school version of that, it would have been a multi-process application where that process would have forked copies of itself. And that's where that fork keyword from GitHub comes from. And when it does that, it literally makes a duplicate of itself, and then the program has to continue on from there, and they have to ask themselves which one of us is the original and which one is the clone. So you'll have 100 lines of code, and you get to line 30, let's say, and then the program calls the fork system call, which duplicates himself into a second full-blown process. You got 70 more lines of code from that point forward, and maybe the original process does the first 35, and the cloned process does the second 35. That way you have two different tasks happening at once, right? One's checking email, one's writing a new email, something like that. But those two programs have to decide who does what. So they have to ask a question after that fork command saying, who's the clone? Because they don't know. They have to ask. The result of the fork command is a process ID, a unique identifier, kind of like your foo number, right? That tells you who you are in the system. And the parent's process ID will be 0. Theirs will not have changed. That's, I'm the original. But the child will say, well, my process ID is not a 0. I'm the clone. So I need to do what the clones are supposed to do in my logic here. All right? That's a little OS lesson, somewhat unrelated to what we're talking about here, other than the idea is that now we have, whether it's two programs related to each other or two threads that are related to each other, because the more modern way of doing this is something called multi-threading, those threads might need to talk to each other, right? So perhaps your email client, if it's doing two separate things at once, it might need to maybe send information between the two sides, right? Maybe when you're writing, you're composing an email and you actually hit the send button, maybe that guy doesn't actually do the sending. Maybe it goes through the normal email client, which then talks to the networking subsystem of it that actually sends the email out. And they need to do some communication between those different programs. That makes sense? So in an operating system, we have a bunch of running processes. Now, the same thing is true in Android. Android is an operating system, right? But we have a level of abstraction that we're talking about here with our with Android. So I'm just going to kind of talk about it through our level of abstraction. So Android development, we have a bunch of running activities. All right. So an activity is kind of like a process. And we might have a situation where our second screen needs to get some information to our first screen. That makes sense? Now, if we think about this in real life, so again, this is, computer science is typically, we think about it from the perspective of how do human beings solve problems, and we try to mimic that. Programming languages attempt to do that, but the way computers work, they're meant to be tools for us to solve problems. So at some level, we've created abstractions. We've created power tools that allow us to interface with our computers in some sort of interesting way. Now, do human beings rely on communication? So if we think of the world as an operating system, and we're all individual processes running on this operating system, all right, we're moving through the operating system, we're doing our own things and stuff like that. Do we communicate with each other? Do we have kind of various levels of detailed communication? So sometimes we'll have a direct conversation, right? Where we're really sharing much more detailed information. But sometimes you only need kind of like a quick communication. So let's say somebody's meeting you for lunch, and they'll say, "I'll meet you in there in 5 minutes." You might just say, "Thumbs up. Sounds good," right? You've signaled them that you've received their message and you're good with it. No more details were exchanged other than that. Is that a form of communication? Yeah, but it's simplified, right? And we only have like a fixed number of kind of hand gestures that mean something. Otherwise, we're out there miming, right? That's the whole premise of like in baseball with the coaches doing they're sitting there just messing with their cap and do all the signs, and only like 5 of the things that they're doing actually mean something. And you're looking for those signs. But human beings, we have our 2 or 3 things that are like common signals that everybody might know. And then among your friends or something, you might have some very special secret messages or something like that. Okay, but the idea is it is limited communication, but can be meaningful in certain situations, right? Other times, you might want to have real-time communication and talk to them immediately. Maybe you need somebody to hand you something off the desk. Like, hey, beginning of class, I say, hey, can somebody hit the light button, right, over there? So that's like a request to all the running processes in the room to see for a very specific task, but it's a real-time request. The expectation is the lights go off soon, right? Now, let's say that somebody needs to, we have one of our employees or something like that at the university, and there's some task they need to complete, but it needs to be done by Wednesday. We might think of like IT works this way. You can put something into the ticket, the ticket system, right? And that goes into their ticket system and gets assigned to somebody, but that is the idea is that you've put it into the ticket system and then they will come and find it. Maybe they get notified, maybe they don't, but they will come into the ticket system, log in as themselves, and realize that, a ticket has been assigned to me, right? So in operating systems, that ticketing system would be called shared memory, where you have a common place that you might put a message that everybody can feed from. So an OS, you could say shared memory is like a IT ticket system. Android development, maybe we say something like a singleton is like an IT ticket system, something like that. We have this common place that we put stuff, and only when somebody goes and checks it is that maybe meaningful. All right. Then human beings actually use the IT ticket system. that's our way of accomplishing that. And So this is our, IT ticket system. Now, human beings, when we wave at somebody, which is our universal signal of saying hi or saying bye, right? Or we do the thumbs up thing, okay, whatever it is, that's, so, waving / hand gestures. Just steal that here. In an operating system, we have these things called signals. And that's our waving / hand gestures. And we can actually accomplish the same thing in Android, but for right now, we're not looking at that. So I'm just going to leave it. You actually can signal threads through a wait and signal type thing, but we're not dealing with threads yet. But know that it exists. It's part of this guy. Okay. So that's another way we might communicate. Now, another way we might communicate is talking. Whether it's face-to-face or on the phone or whatever, that we would call that direct communication, right? Talking / direct real-time communication. So in operating systems, this would be done through a socket or a pipe, depending on whether you were going over the internet or staying local on the operating system, because you can talk to another computer through a socket. You can actually talk to the local computer through a socket as well, but sockets rely on the TCP/IP network stack. But if you're not leaving the computer, you really don't need that. So you might as well use the local phone system. So kind of like a pipe is like here on campus, you can just dial an extension. It never leaves campus. Where a socket is like dialing a phone number, which gives you some remote address. You're calling Qdoba to place your order, something like that. All right, but socket or pipe, this would be like real-time communication. You actually could do the exact same thing in Android, so I'm not even we'll just kind of just do our dot thing again there, because we're not talking about that at this point. But you're seeing similarities here, right? Where how human beings communicate, and how we've mimicked those ways of communication on our modern, operating systems or communication channels or something like that. That makes some sense? All right, so in any case, one of the things that we want to consider is what kind of communication do we want to create? What makes sense? Don't you hate when somebody sets up a meeting with you when it's something they could have just done by email or a text or something like that? Or they send you an email or a text and it really needed to be a meeting. there was a lot of back and forth question answering that would have been efficient if done in real time, right? So there's kind of a right tool, a right way of communicating for different tasks. All right, we want to have those options. So when we're dealing with Android development, one of the things we can do is we've been working with singletons here, right? So communication in Android, we'll call this singleton communication in Android, and you can extend this to iOS or really any type of software. So we really have this idea of signals versus shared memory. So, and we kind of can implement them both through the singleton thing. So we can do the shared, well, let's call it store data for later retrieval with notification, or let's say with scheduled check-ins. So with this kind of approach, we might have activity 2 sets a value in the singleton. Activity 1 leverages the activity lifecycle to always check the singleton for new messages upon, let's say, resume or another time in the life cycle. So that would be two screens kind of actively communicating. Screen 2 might set a value, and when you go back to screen 1, we can have that value checked. And we're going to see that here in a few minutes. So let's actually do that version first. Okay? So what I'm going to do here is we're going to go to our screen 1, activity main, and I'm going to throw a text view out here. And we'll bump the font on it way up so I can read it. All right, and we're going to call this guy employee count. Actually, I'll do it lowercase. Employee count TV for text view. All right. Now, this employee count TV is only accessible when you're in the context of this activity. So what we're going to do here, now remember, we have it in our notes here, we have our activity lifecycle. So notice here that on resume gets called every single time. It gets called when it first launches. It also gets called when we come back to this screen, right? So what I can do is in my first activity, so I've given myself a name for this text view so I can set it to something. I'll go into my main activity. I'm going to go ahead and give myself access to that guy. So I'm going to make him a, well, I can make him a global variable, but if I'm not going to use him anyplace else, we can just do it inside of onResume. So I'll just start typing onResume here. And it gives me the kind of the outline for it. Just press enter, and it will now let me override that because I commented out my other one. So now this code, this will happen every time this screen is about, actually I think it's already shown up on the screen. I think it's about to show up on the screen. That is the very first time as well as each subsequent time that it might show up on the screen. So what I'm going to do here is I'm going to go ahead and I'm going to get my text view. So I'll say text view employee count TV is equal to this dot find view by ID r dot ID dot employee count TV. Now I want to set this guy's text to the current number of employees. What's the current number of employees? Who knows the current number of employees?
Good question. That would be
Good.
well, it would be listed under the employee list activity. How many names the user can hit.
Okay, and where's that stored?
I think it's under the employee entry activity.
Okay, so employee entry activity, when we create a new employee, he actually updates our list inside of core, inside of our singleton. So our singleton is actually the guy who stores an array list. And that array list will have a size. So whenever we want to know how many employees we currently have stored, we can consult the singleton, specifically asking our employee array list, how many are there? That make sense? So I'll go back to main activity, and we're going to say employee TV dot set text. Now I want to set this guy. So here I'm gonna trick you, and then you're going to tell me why this is wrong. So we're going to say core dot the employees dot size. Notice this has not given me an error. What kind of value is core.theemployees.size? Cat, dog, or integer? It's an integer. It's a number of things in there, right? It's a count. Okay, this is a count. It's the size, the number of elements in that list. Now, set text. So here, I'll run this real quick, and we'll see it crash. Because this is a common mistake. That's why I'm showing it to you.
And survey says, and.
Okay, there's our crash.
Oh, yeah.
And you may say, oh, well, why did this crash? Now, notice here, where's my, on resume. I'm just going to start typing in employee count TV.set text. Notice here that there's a bunch of versions of set text. Now, we typically use one version. Let's get a second one right here that takes in a character sequence. It's effectively a string. All right, it takes something that is a character sequence, and I promise you that string is a character sequence. Well, actually, a character sequence is a string. It inherits from string. All right, but notice there's another one of these guys that takes an integer, and that integer is the resource ID. So every single one of our resources in our, so all of our widgets, all our text views, things like that, they are assigned a unique identifier. Social security number, a food number, think of it like that. So they're assigned an int that uniquely identifies them in this Android application. Now, the way they would encourage you to use this is to use one of those string XML things to fill the text for this so that it's language independent. So all the strings that you might store inside of your string XML file are also given unique resource IDs. So this particular version of set text that takes a resource ID, it's expecting me to give it the unique identifier for one of the resources, presumably one of my string resources in the system. So why do you think it's crashing right now? What resource ID am I currently giving it the very first time the application launches? 0. So this is only going to work if there just happens to be a resource ID of 0 or a resource ID of 1. Now, there was actually legitimate risk, depending on how they implemented it, that the very first thing they give out is a 0. Then it would have worked, but given me weird feedback. Like, why is it giving me some sort of gobbledygook that has nothing to do with what I was asking for? See how this can be confusing? All right, so I want the version of set text that takes in a string, a character sequence. So how do I turn this number into a string? I've asked the same question in class several times, and this is one of our go-to moves in string-based languages like Java and C#. Okay, what's the easiest string to concatenate with it so we don't change the value? If I want it to still be 0 the first time and I don't want it to say like number of employees equals. No, getting colder.
Did you just do like double quotes?
Yeah, the empty string.
Oh.
The empty string concatenated with my number.
Right.
You can turn a primitive like numbers, doubles, ints, longs, those kinds of things. You can turn those into strings by concatenating them onto the empty string. That makes sense? That did not work in Python. Remember, in Python, the concatenation operator only worked if both sides were string-based. In Java, only one side needs to be a string for it to identify that plus sign as the concatenation operator. Same thing's true in C#. In fact, you would find that pretty much anything that is true in Java is also true in C#. I'm sure that's not a 100% truth, but we're in the high 90s, very high 90s, because C# is very much built to be the direct competitor with Java. It was deal with the political issues at the time and lawsuits and stuff like that. But for all intents and purposes, they're the same language. All right. So now I have the string representation of that number, which will not get confused with some resource ID that might be out there. Does that make sense? Everybody's assimilated that common mistake into their head? Because at some point in the future, I promise you, you're going to have an app that's crashing and you don't know why. And it's going to relate to that type bug. All right? So sometimes one thing you can do is, if you're like, well, I'm passing it, but I think I should be passing it, go ahead and just give yourself another line. Employee TV.setText. So start your function call and just look at the different versions that you have here. You could also go to the documentation and see it and see if maybe you are calling a different version of that method than you thought. What's it called when we have more than one method with the same name but a different number and or type of parameter? Polymorphism. All right. Now, we can say that it's funny and you should have that word memorized, but I don't think that you're going to drastically impact the success of your career if you don't recognize the word polymorphism. But you should know that you can have more than one method with the same name that takes in a different number or type of parameters, because that's
important.
common all over the place. In fact, in most modern libraries that you might use, it's probably somewhat uncommon to have a commonly used method only exist in one form. More often than not, it's going to have 2, 3, 4, 5 versions. And that goes to constructors too. There's usually several different ways of building a type of thing, because you might have different building blocks, right? You know, if I want to build a house, I can hire a contractor to build a house. I can hire, nowadays you can hire a tech company to come out and 3D print your house, right? You know, contractor's going to want a blueprint or something like that. And the 3D printer guy probably already has, look, this is what the house looks like. If you haven't watched the YouTube video, it's fascinating to watch them 3D print a house.
Isn't there issues with like the heating and stuff like that? Because they're, like, fine.
I mean, I'm sure there are some limitations, and maybe that's why the model they use is very specific.
Yeah,
But I'll tell you what, they're building the house in an afternoon with a
that's
3D printer on a crane. It's any way you cut it, it's impressive.
And
You know, even if you're not moving a family of 4 in there. You know, it's,
it's pretty much in third world countries for the most part, you're right.
well, maybe now, but it's already popular here in the U.S. to have the tiny homes.
Yeah.
And the tiny homes are smaller than the 3D printed stuff. So, I mean, I can see there being major businesses surrounding tiny homes in general, but also 3D printed tiny homes. Because there's plenty of people that don't need the space. I mean, that's kind of the argument. I mean, this is even related to what we have talked about today, these overlaying things in computer science, these grand ideas, and the same thing goes with technology. You know, if you think about the areas of your house, what are the required things you have to have in your house? Well, you probably have to have a bed, some place to sleep, right? Probably need to have a bathroom. Okay, we can't leave those 2 things out. I mean, you can say I'm going to sleep on the floor or something like that, but that's not going to be healthy for a person, right? Okay, but do you need to have a living room with a big screen TV in it? We might say we really, really, really want to have that, but what's the biggest TV you can buy for your house, realistically? Or maybe the better question is what's the biggest TV you could buy for your house, and then what's the biggest TV that you realistically could afford to buy for your house? Huh?
An iPad.
So, well, actually, you can buy some big screen TVs for less than an iPad. Most big screen TVs for less than an iPad. So the reality is that maybe the biggest TV you can actually buy for your house that like human beings could marginally afford might be like a 100-inch TV, but they're still going to be really expensive, right? So in terms of like normal folk, like, hey, I have an IT or computer science job, maybe it's a 75 or even an 80-inch TV. You know, we're starting to get into that realm of like, you know, the $3,000 to $4,000 range for a TV, maybe even $5,000. Anything more than that's starting to become pretty prohibitively expensive, right? But you can get like a 65-inch TV or a 60-inch TV for $400 or $500-$600, right? So you're not giving up tons. But if you go out and get an Oculus Go for $200, you can watch your Netflix on a movie screen, 100-foot screen. And you don't need a whole living room for it, right? So technology is going to create these trade-offs for those types of things where now you don't need that living room that only can have a 100-inch screen in it. You wouldn't watch the Packers game on a movie screen. Do that in virtual reality. So we're going to see those things kind of take over. What's the other advantages of having a tiny home? Well, a lot cheaper to heat, a lot cheaper for electricity. All these things add up to a more economical environment. So now all of a sudden you can decide, well, what makes sense for you? What's the right tool for the job? If you are, married and you have 11 kids, tiny homes are probably not going to be a thing. You more need a medium-sized barn. That's so something like that. We get the idea here?
Yeah.
All right. So when you're going through these various classes of computer science, and remember today's the Bible study, so meet me in there. But when you're going through these various classes in computer science, try to keep a framework in your head that just because the class has a different topic, there's very likely some nuggets of overlap with other classes. Try to find those because it might help you understand some concept that was otherwise hidden from you. All right? No homework because we have Thanksgiving coming up, so the next time I'll see you guys is on Tuesday. Do remember that there is Bible homework due by Sunday, so I would encourage you to just knock that out today or something so you don't have to worry about it. All right? Everybody be safe in your travels.